Welcome to Study Loop.
So in this question, if you see argon flowing at subsonic velocity, and the element is argon in a constant diameter duct is accelerated. Acceleration is done by heating. So the highest rate of heat transfer and that also the highest rate is to be determined here. So certain assumptions are there which we have to consider in this case. So the assumptions in this case are, the first one is steady one-dimensional flow of an ideal gas with constant properties through a constant cross-sectional area duct with negligible frictional effects are valid. So that is one-dimensional flow is there, ideal gas is there, constant cross-sectional area is there of the duct, and negligible frictional effect. Frictional effect is negligible. So these are the assumptions that we have to see. This is the first one. And the second one is that the mass flow rate remains constant. Mass flow rate remains constant. So these are the two assumptions that we are seeing. So here, before we come to the analysis of this question, we have to see the properties. So for argon, we have K equals to 1.667, Cp equals to 0.5203 units. Then we have the R to be 0.2081 units. Now we come to the analysis part of the question. So heat transfer stops when the flow is stopped. So there is heat transfer continues till there is a choke. It stops when flow is choked, and thus what happens is Ma2 equals to V2 upon C2 that equal to 1. Now the inlet stagnation temperature. First we are considering the inlet stagnation temperature. Inlet stagnation temperature in this case. So that will be TO1 equals to T1 upon 1 plus K minus 1 upon 2 Ma1 square, that is equals to 400 K 1 plus 1.667 minus 1 upon 2, 0.2 the whole square, 405.3 Kelvin. The radial flow function corresponding to the inlet and exit March numbers are T02 upon T0 is equals to 1 since Ma2 equal to 1. Hence we have TO2 upon TO1 equal to TO2 by TO upon TO2 upon TO. It is 1 upon 1.9 0.1900, and the value would be equals to 2133 Kelvin. Now the heat transfer rate. That is the question, right? The rate of heat transfer. That is Q is equals to mass of air into Cp TO2 minus T01, and that is 1080 kilowatt. So this is how we find out the answer. I hope you understood.